Alright, thought I'd come back over here to the lab and go through a few of the things that I asked you to do for me in terms of identifying equipment and reading some of the instruments that were set out for you to read. First of all, we talked a little bit about the lab safety, make sure everybody understands some of the important components of this lab and how it's put together. Over here in the corner of the room, that is the lab safety shower and eye wash station. Shower is operated with this silver pull handle. You pull it down, tons of water come gushing out of there, wash any kind of chemicals off of you that you might have spilled on yourself, or if for whatever reason you burst into flames, it would put the fire out. This is the eye wash fountain. To operate it, you just push the handle backwards, water comes on, you stick your eyes in the fountain for 15 to 20 minutes to make sure you rinse anything out that might be in them. In the back of the room, on the wall, this is the cabinet that houses the extra fashionable safety glasses. And if I tell you to wear safety glasses, you make sure you've got them on. There's some kind of eye hazard that we need to worry about. And again, those are sterilized between each class, so you don't have to worry about getting any strange kind of eye fungus from the person that wore it before you. In the front of the room, fire extinguisher and fire blanket. Again, fire blanket should someone catch on fire for whatever reason, and the fire extinguisher should something catch on fire. In all my years of teaching, never have actually had to use it. Hope that continues. Again, the basic rule of thumb in lab is that you don't horse around, you do what you're asked to do, you only perform experiments that I ask you to do. If you do those kind of things, then no one's going to get hurt and things are going to be just fine. I asked you to identify some equipment for me. This was the first one. This little device here is a beaker, specifically a 100 milliliter beaker. We use beakers for moving chemicals from one place to another. We use beakers for conducting experiments with larger amounts of liquids. This is a heat-treated one. This is a Pyrex beaker, so this can be used to heat liquids as well. Over here in Station 2, this funny-looking device with a thin top, thin neck, is called a flask. This is a 500 milliliter flask. Again, it's Pyrex, so it can be used for heating liquids. What makes this different from the beaker over there is that it has a narrow top that allows us to put a stopper in it. So if we needed to put a stopper on our liquid, this is what we would use. Can't do that with the beaker. This also allows us to mix things because the narrow top prevents splashing. It can be used for measuring volumes. We don't use it very often for that because of its lack of accuracy. You'll see it's marked off from 0 to 500, and it's marked off in 50 milliliter increments, so its accuracy is relatively low, but it could be used for measuring larger volumes if the accuracy doesn't have to be there. That's a triple beam balance. Balancer used to measure our masses. When you're working with these two, the beaker and the flask, if you're measuring in them, you're measuring volume, you're measuring in milliliters. When you use the triple beam balance, you're measuring masses, you measure those in grams. You're asked to identify this device for me. This thing here is a graduated cylinder. It's not as fancy as the one from the other video. This is a plastic one so that it doesn't break. Again, it's 100 milliliters, just like the one in the other video, marked off in 1 milliliter increments. Used for measuring our volumes. That's a funnel, and the use is pretty obvious. If I have to pour something into a container with a thin neck, use a funnel. That'll prevent spilling. And when you're dealing with chemicals, preventing spilling is always a good thing. These are tongs. You were asked to identify those. Tongs are used for picking up things that are hot, for moving like beakers off of burners and things like that. It's important to remember though, when you're removing your beaker from your burner, hot glass looks like cold glass, so never touch it with your hands if it's been heating. Use something like the tongs to use it, to move it, to pour it, that kind of thing. Always remember too, if that beaker is hot, don't set it down on these countertops. These countertops are pretty cold, and when that hot beaker hits that cold countertop, it can shatter. We want to avoid that. But these are the tongs. Those are used for picking up things that are hot, moving them around. Again, like a beaker that was just on a graduated cylinder, or a beaker that was just on a flame. Test tube clamp. What the test tube clamp is used for is kind of like these rings are attached to the ring stand. We can take this test tube clamp and we can attach it to the ring stand too. So if you were asked to heat something and a test tube. Just unscrew that, clamp it on to the ring stand, and we don't have to hold it over the flame. The clamp holds it for us. But that is a test tube clamp. You were asked to identify this. That is the ring stand. And again, you can put rings on it like you see here. The ring would have a screen that sits on top. You can put a beaker on it, put it over top of a Bunsen burner. Or we can use the test tube clamp over there, attach it to the ring stand to hold our test tubes over a burner. You were asked to measure the length of this particular object. And I see someone so cleverly wrote the answer there, 6.5 centimeters. It's wrong, so if you copied it, that is the incorrect measurement. We are starting on the 1 because, again, the end of the meter stick is rounded off, and we never want to start there. We are between 7 and 8, so it is 7 point something. The way I see this is 7.25. Or subtract 1 from it, so we'd get 6.25. So whoever wrote that, that's not the right answer. Had to read the balance for me. And again, to read a balance, we just add the 3 beams together. We got 0 on the center beam, plus 30, plus 5.9. So if I read that, I'd write down 35.90 grams was when I had it set up. It was exactly on the 0.9. You had to actually measure a mass over here. And again, if you didn't watch the last video on the types of measurement and using the equipment, you make sure it's zeroed, put your object on it, adjust the sliders starting in the middle with the big one first, 1 notch at a time until the needle falls. When the needle falls, back it up. Then you move on to the 10s, you move it over 1 notch at a time until the needle falls. When it falls, you move it back. You finish by moving the front slider around till you got it pointing to 0 like it is right now. When you're done, you just add the 3 beams together and you've got your answer. You've got your mass for your object. And the mass of this object appears to be 50.30. So 50.30. Again, it's exactly on the 0.3 marking, so I put that 0 on the end to indicate that it's exactly on a marking. Over here, you had to do a volume for me. This is one of the smaller graduated cylinders, and it's kind of hard to see on the video because it doesn't focus very close. The liquid inside is curved. You can kind of see it by that dark band you see there. And we always read from the bottom of that curve. And again, when we read the graduated cylinder, we want to make sure that we get down on its level and we're looking at it from here. We don't want to be way up high. And as I read this one, this is a 10 milliliter graduated cylinder. Each marking on this one is 0.2 milliliters. I'm looking at the markings, 6 to 8. That's a 2 milliliter difference. I have 10 markings in between, so I take 2 divided by 10, it's 0.2. Looking at this, I am between 5.6 and 5.8, so I would call that 5.7 milliliters. Big one over here, again, graduated cylinder. Again, the liquid will be curved inside, and like I said, it's kind of hard to see because it doesn't focus very close, but you can see how there's a dark band at the top. That's because of that meniscus. And again, we're going to read it from the lowest point. We get down on its level. Each one of these is 1/10 of a milliliter. This one is exactly on 39, so we'd say 39.0. If that's what you wrote down for that one, you got it right. And finally over here, that's a Bunsen burner. Bunsen burners are used to heat objects. We would take these little gas nozzles here, hook a rubber hose up to it that ran into the Bunsen burner to get ourselves a gas flame to heat things up quickly. And that's just a quick review of some of the lab safety stuff that we talked about, and a run through of the questions that I asked you to answer for me on our little lab practical.